Question 30. Water is leaking out of an inverted conical tank at a rate of 10,000 centimeters cubed per minute at the same time that water is being pumped into the tank at a constant rate. The tank has height 6 meters and the diameter at the top is 4 meters. If the water level is rising at a rate of 20 centimeters per minute when the height of the water is 2 meters, find the rate at which water is being pumped into the tank. Alright, so here's our cone. And we're given the height and the diameter. So it says the height is 6 meters. Which we know is equal to 600 centimeters. And the diameter is 4 meters. So that makes the radius 2 meters, which we know is equal to 200 centimeters if we convert it. And we're asked to find the rate at which water is being pumped into the tank. So what we know is that water is leaking out of the tank. O for out is 10,000 centimeters cubed per minute. And water is being pumped into the tank at a constant rate, so that's what we're trying to find. So that's going to be I for N. That's what we're trying to find. And the water level is rising at a rate of 20 centimeters per minute. So that's going to be dH over dt is equal to 20 centimeters per minute when the height of the water is 2 meters, which is equal to 200 centimeters. So the total rate, or the rate of the volume changing in the tank, dV over dt, is going to be equal to the rate at which water is being pumped into the tank plus the rate at which water is being pumped out. So we're given the rate at which water is being pumped out. So that leaves us with dV over dt equals di over dt minus 10,000. Okay, so now when we have the formula for volume, it's 1/3 pi r squared h. So when we try to take the derivative of this, we're going to have dr over dt, which we don't have. We're not given that. So when we take the derivative right here, we have dr over dt, and we're not given that. So we need a way to get rid of this. So we're going to use the properties of similar triangles to get rid of that. So here's this right triangle right here. This is what I'm doing. So here's our right triangle inside that cone. And here's the radius right here, which we know is equal to 200 centimeters. And the height right here, which is equal to 600 centimeters. And here's that right triangle from the water rising inside. Right here. So that's R and H. So since these triangles are similar, 200 centimeters over 600 centimeters is going to be equal to R over H. And so if we simplify this down, we get 1/3 equals R over H. And then just cross multiply and you get R is equal to H over 3. Okay, so now we can use this to plug it in to the volume formula. So in doing that, we're just getting rid of the variable r, so we don't have dr dt when we find the derivative. Okay, so now we're going to plug that in to get 1/3 pi h over 3 squared h, which equals 1/3 pi h squared over 9 h. And so that further simplifies to 127 pi h cubed. Okay. And so now we can take the derivative of the volume. So we're going to implicitly differentiate right here. So dv over dt is equal to 1 over 9, and that's from taking 3, putting it over here. That's 3 over 27, which simplifies to 1 over 9, pi h cubed dh dt. And so we know the height, and we know the rate at which the height is changing. So we can plug those in to get 1 over 9 pi 200 squared times 20. So if you multiply those together, you're going to get 800,000 pi over 9. So now we have our dv dt. And we also, so from up here, we know that dv dt equals di dt minus 10,000. So we can set those equal to each other. So we're taking di over dt minus 10,000, and we're going to move that and set it equal to 800,000 pi over 9, since they're both equal to the derivative, or dv over dt. So minus 10,000. Okay, from here, you can just add 10,000 to the other side. And that leaves you with di over dt is equal to 800,000 pi over 9 minus 10,000. And so to get our units, let's go back up here. We have height squared. Height is in centimeters. That's just going to be centimeters squared. And we have dh dt, which is centimeters per minute. So that's going to look like centimeters squared times centimeters per minute, which just equals to, or which multiplies to, centimeters cubed per minute. So that's going to be our unit. So that leaves you with the rate at which water is being pumped into the tank is 800,000 pi over 9 minus 10,000 centimeters cubed per minute.